Hi, welcome back for another 5 Caillou challenge called How Many Numbers? And it looks like it's a part 2. I'm not going to read this to you. The wording's not very good, and you know how to read. You can pause and read this yourself. I'm going to try to add helpful notes to make the confusing language a little more clear. Basically, you are going to start at 1,000, and they're going to give you a range maximum. You can think of this as your minimum, and they're going to give you a range max. In fact, I'm going to rename these because they're named poorly. And so you can imagine it can get very big. It might have more than 4 digits. So they give an example here where, let's say you had 6 digits, and they're just calling them D1, D2, etc. to D6. And what they're looking for is that this max sum value for any 4 consecutive digits, starting with the first 4, that's what this would represent. This would mean starting at digit 2 and going through digit 5, etc. for however many digits are in the number that you're looking at within the range 1,000 to range max. The sum of those 4 consecutive digits has to be less than the value they provided here in max sum. So hopefully that is more clear than what they wrote. And then note that you'll return this long array, and it will contain exactly 3 items. The first one's going to have the amount of numbers that satisfy the constraint presented above. So you can imagine you'll be looking through the range and finding these, and you're just going to note how many matches you find. For value 2, you're going to use the closest number in that collection you found in number 1, the closest number to the mean value. And remember, for the mean, you can sum up all the values and divide by the number of values. That's just a basic mean average that you most commonly probably think of when you hear the word average. If there are more than one, the smallest number should be chosen. So if you can imagine you find the mean, you look at the element just above and the one just below, and if they happen to be the same distance away, favor the lower one, is all that means. But if the higher is closer, then use that value. And then finally, the total sum of all the numbers found. So that collection from number 1, just add up all the numbers in it, and that'll be your third value. So really, it's pretty easy once you build up this collection of numbers that satisfy the constraint. And then there's an example here if you want to look through it. The one part that might be helpful, we talked about how to calculate a mean there. So you notice they get 1141 for their mean. And so note that 1110 is closest to that mean value. So 1141 would fall in between these two values, right? And so clearly 1110 is closer. It's only 31 away or so than 1200 is, which is more like 60 away. And then, yeah, summing up all the numbers, think that's clear. I think you're good to go. So why don't you go ahead and pause the video and start this one. I'm gonna clean this up a bit. I already renamed my variables. And then just unpause the video when you're ready. So they gave us that range minimum, if you will. I'm going to call it current, and we're going to start at 1,000 for our processing. And then I'm going to make this collection that I'm going to use. Well, we're working with long, so use long. I'll call it matches list of long, initialized, ready to go. And so every number I find that meets the constraint, I'm just going to load up into this list, and then it'll be easy for me, pretty easy to return the 3 values that they're looking for. So good, I'm ready to go with my matches collection. So not going to do anything fancy. We're going to go while current is less than or equal to range max. So we're going to start at 1,000, and we're going to keep going up, and I'm just going to bump it by 1 every time, right? We've got to update so we don't just keep looping forever. And this will step us through each value, 1,000, 1,001, etc. until we hit the max. Good. So now let's start looking at the values. And I'm going to make that helper method that we've used in many other videos now to get the digits of a number. I've been calling it get digits. It'll be a long here, and hopefully you've remembered how I do this by now. List of int digits equals new list of int, and then we say while n is greater than 0, we're going to peel off the least significant digit. So I'll say digits add, and I'm going to go ahead and make mine a long so I don't get yelled at. And I'll say n modulo 10, right? That'll give me the remainder of dividing by 10, which is the least significant digit. And then we have to update, make sure you divide n by 10 each time so we don't get stuck in the while loop and we keep updating and getting the right digits here. Note again that the digits will be in reverse order, but that doesn't matter at all because we're just doing addition, and the order of addition doesn't matter. So, and we're taking contiguous values, so it doesn't matter if they're going forward or reverse. If it really bothers you, you could reverse this collection to get it in the right order, but I'm just going to leave it. Instead of get digit, I'm going to call it get digits. I like that better. Oh, it's a typo. So good. That'll make things a little bit easier. Then we can come in right from the start, right? And we could say, oh, and I messed up here. It's got to be list of int, right? It's a collection of digits. So good. While I'm here, I'll grab that and I'll say list of int digits equals get digits for the current value that we're on. Good. So we've got the digits. Now, what do we do to find the constraint? Well, we're going to be summing groups of 4 numbers. So imagine a sliding window starting at the beginning and sort of size 4 and progressing throughout the number of digits we have. It could be 4, it could be 10, we don't know. But we want to check contiguous groups of 4. So think of it that way. We're going to kind of have a sliding window that happens here. And so to do this, I'm going to make a for loop into I equals 0. And I'll say I is less than digits count. And then I'll say, well, I mean, since we're doing the window size 4, right, I'm actually going to subtract 3 because we're going to look ahead 3 spots. We're going to grab the current digit and then 3 ahead. So that's why I'm doing digits count minus 3, right? I wouldn't want to go, I don't want to omit this, right? Because then I'll go right up to the final digit. I'll try to look ahead, but there's nothing ahead, right? So I hope that's clear. And then plus plus I. Okay. All right, good. So let's get our collection of digits to look at. So I can say if digits, and I'm going to say skip. We've seen skip. And I'm going to skip I. So the first time I is going to be 0, and it's going to say skip nothing and start right with the first value in digits, which is what I want. And I'm always going to take 4, right? Because we're looking at groups of 4 at a time. And then what do we do with those 4? Well, we add them together. And we want to make sure that they're less than the max sum. And now to sort of achieve this, what I'm going to do is set up a Boolean flag here. I'm going to say Boolean all pass, and I'm just going to say, let's suppose it's all true, right? And then if we encounter any one of these size 4 groupings that don't pass, right, meaning if they're greater than max sum, what I'm going to do is say, uh-oh, all pass is not true, it's false. And I'm going to break out of this for loop, right? Because there's no need to keep looking for more digits, right? Because if one group fails, the whole thing, the whole current is thrown out the window, right? It can't pass. So I'm just kind of short-circuiting here and saying, hey, get out of here. We know this one's a failure. And then I can simply check if all pass. Then we will say matches add current, right? that means we went through this, we looked at every group of 4 in a row, and they all met the criteria. And so then we'll add matches. And you can imagine, then we bump current, right? And we step through. This is the end of our while loop. And so after we've gone through that, we've scanned the whole range, and we can start working on that return value. So we're going to return a long, and we're going to have 3 values in here, right? And the first one was pretty simple. It was the amount of numbers that satisfy the constraint. So you remember that list has a count property. That's going to tell us how many elements are in the list. Perfect. Number 2, the closest number to the mean of the results. So this is a little more involved. I'm going to actually make a helper method to get this. Let's delay that for now. And number 3 is the total sum of all the found numbers. Well, we built up this collection here with all the found numbers, and we can say sum like we did before. Oops. So now it's just a matter of getting this other value. And instead of cluttering the main method here, I'm just going to do the logic somewhere else. Private static long, right? It's going to give us a long, and we'll say, how about get nearest to mean? And that's going to be based on a list of longs. Values, I'm just going to give it a generic name, but we're going to pass our matches collection into this. And so what do we do here? We can start by gathering the mean, and we can say values dot average, and that's going to give you a mean average. Where is that? I don't know if we've used average in this series, but if you go into the enumerable methods that we usually keep open, you'll find average. And if you want to read about that, go ahead. It just gives you the mean like you would think, nothing special to say about that. So good, we've got this mean value. And I used a double, right, because it might not divide out evenly. We saw when they did it, it was this 1141 and some change. So that's why I'm using a double right now. And then, okay, good. So now what I want to do is, now that I know the mean, I sort of want to straddle that. I want to find the first value in my collection that is above the mean, and then I'll know that the previous value will be below the mean, and one could possibly equal the mean, right? So let's do that. So I'm going to use, I'm going to go into values, and I'm going to find the first value that meets that criteria. I'm using n because longs are integers, and n is just a good throwaway integer variable name. So I'll say n is greater than or equal to the mean. So that's going to find the actual value. It's not going to give us the index. And you can go into list, methods, and find, if you want to see that. Actually, let me see. Actually, this is what I want. This will make it a little bit simpler. We'll use find index, and we'll give it the predicate like we made already, because ultimately I want to get the index to work with. So let's try find index. Find index, and let's say int index equals that. And let me make sure this looks right. We'll go down. Returns the zero-based index of the first occurrence that matches the conditions. Yep, looks good. So find index, that should give us the index of 1 past the mean value. And so we know the previous one is just index minus 1. Good. So now let's calculate some differences to see which one's closer. I'll call diff high, and for this I'll say the values at index minus the mean, right? And we'll do the same thing to find out how far away the lower value is. And this will be values index minus 1, and we'll take mean minus that, because right, this one the previous value should be lower, or right? And I want both of these values to be positive. That's why I did that. If you could do it the other way if you use absolute value, but just make sure that you're getting the magnitude of the distance from the mean. That's the important part. And so once you know this, the magnitude of this difference, you can say return is diff high less than diff low. That means diff high is closer, right? And if it is, you would say values index, that one's closer. And if it's not, then it means the lower one's closer. And note in the condition that they were the same distance, it should favor the lower value, and that should meet that criteria as well. So now that I got this handy method, I should be able to do this, get nearest to mean matches. Okay, and now I used a lot of libraries here. We use some LINQ. Let's bring that in. Let's bring in system. Remember for list what we need? System collections generic. I'll hit a test, see what I did wrong. Okay, line 50 cannot convert from long to int. Let's fix that. Line 50. There's 50 digits, add. Oh, so n was a long. I meant to make it an int. I don't know why I cast a long to a long, but yeah. Okay, good. We hit some green there. Let's hit the bigger value, or bigger collection, I should say, of tests. And we are clear for takeoff. So yeah, we basically set up the range between 1,000 and max. And then nothing fancy, just started at the low end, started incrementing by 1, checking each value. Had the helper to get these digits, make it ready to work with. We got a flag set up. We go through a sliding window here, right, of all our digits, taking 4 at a time, starting at the beginning, proceeding toward the end. And if any one of them violates and goes over maxsum, we say, nope, this current value is not acceptable. And so we set all pass to false with the idea that we get out of the loop and it skips over this part where you add the current value if it doesn't match. And so, yeah, the other part was pretty easy once you have the collection, right? Count and sum, and then just getting the nearest to the mean value. If this is the first time you've seen average, now you've got that in your tool belt. We got the index, the first one over the mean, and that sort of allowed us to get those to straddle that mean and get those two relevant values, see which one's closer, and then return the value associated with that. So I'll submit. Go ahead and look through other solutions. I'm sure there's some good stuff out there. I bet you have some good stuff. Go ahead and drop that in the comments. Otherwise, hit me up and we'll keep rolling. We'll keep cranking out challenges. Thanks for watching.